to the cloud. So we are here by the Dulles Airport, at least Toby and I. Is Uday here as well in this area? Uday?
Yes.
Yep.
Ashburn.
Awesome. And it's quite nice here today. I wouldn't call it, I'd call it spring, a cool spring day
Hmm.
on the cooler side. And
Fall-like weather.
right, except for the daylight, but yeah. So we are wondering, oh, you're in Reston, in Baltimore. Okay, so you all are like us. Nice. Frank and James.
Hello, Gawain. Long time no see.
Paul is from Canada. Nice. Cincinnati, Ohio. Nice. Is this Canada East Coast, Paul, or West Coast? Just trying to see local time for you. Ontario.
That's our coast.
So, Toby, are you planning to take another of your long road trips, maybe this time beyond?
I don't know, no plans yet.
Hmm,
Probably some shorter trips.
okay. See, do we have any more people waiting?
I just admitted one.
You did. Okay, thank you.
Sure.
So it's going to be exciting today to learn from Toby and Uday. And I'll give it a couple of more minutes before I start the introduction, just so that while people are coming in,
Hmm.
we wait. And
I was just telling Uday earlier, the number of people who sign up versus show up is greatly dependent on the weather. So today is very beautiful. So we'll see how many people show up.
very true.
But we're recording. If people aren't able to join, they can
You
definitely
can.
still see. Yeah.
Awesome. So, oh, there is one more. It's a Samsung number. Someone's joining from their phone, I guess.
How do you know it's a Samsung number?
That's what was displayed.
Oh, I see.
Yeah, I wouldn't. I'm not that clever yet. I do not have RF vision yet. Okay, everyone. Thank you so much for joining us. Such an exciting topic. I'm especially very keen on learning more and more about how AI is changing our personal and our professional lives and everything else that typically influences us and motivates us. So these are very interesting times. And thank you, Toby and Uday, for accepting and coming and presenting to us. So let me introduce both you gracious presenters to our audience. So Toby Rao, he's a transformation expert with 25 years of experience leading change. He's gone all in on AI recently, and he doesn't just talk strategy, but he's in the trenches building it. He's the global director of R&D operations and AI Center of Excellence lead at ExoStar, which is a FedRAMP certified platform serving defense and aerospace enterprises. He also co-founded our Agile network, which has grown to now 2,300 members. He's also finishing up Can I break the secret?
Yeah,
A
yeah,
book.
you can. It's okay.
Yeah, he's also authoring a book. It's called The AI Leap, and I'm sure you'll hear more about it from us in the future. So watch for that one on LinkedIn as well. And thank you, Toby, for coming here and giving us a fantastic session to our audience. We look forward to it. And to Uday. So Dr. Uday Kamath, with respect, is no stranger to us. He's spoken here before, even before AI became hot and fashionable, and we are grateful to have his expertise again. He's been here long before we had chatbots appearing on our screens and our phones and everywhere, customer service and even places where we don't want them to show up.
Mhm.
Um, he is a chief data scientist at BAE AI, and he has led over 100 financial crime AI deployments. He is a leader for digital reasoning, and his platform was used by 90% of the top 20 investment banks. I would love to
Wow.
learn more about Mythos from him for sure. He's applied AI to cancer detection across 170 plus hospitals and to national security challenges most of us will never hear the details of. And we are grateful. He's currently the Chief Analytics Officer at Smarsh. He's authored multiple books, everything from explainable AI and transformers to LLMs and causal inference. He holds 12 plus patents with 60 plus published research papers. So thank you, Dr. Kamath, for coming and sharing your wisdom with us today. Over to you all.
Thank you so much, Meenakshi, for the great introduction. So the title for today is based on, of course, this is the most classic Western movie, The Good, the Bad, and the Ugly, and it's a shootout in the modern times. We're a pretty small group here, so please feel free to unmute and talk. Um, so how many of you in your organizations are at the stage where you're using AI coding agents today? You can put it in chat or you can speak up. Either way is fine. Yeah, so it's very interesting. Last year, everybody was thinking that AI coding agents and agentic AI is pretty far away, right? Some organizations started, but it people didn't think that it's going to go so fast. The term vibe coding came. Everybody was curious. So many organizations have started using it, especially now. You know, half the year is almost over, and we're seeing a lot more organizations using it. So the question is, are AI coding agents helping your organization deliver better, or is it just faster? So that's the topic of today. Um, Meenakshi already went over this, so I'm going to skip that. So a little bit about my experience and practice. So I work for an organization called ExoStar. Our AI journey just started last year in May, actually, just a month after I joined the organization. When we started, we had very humble beginnings. There was some teams using AI. It was pretty disjointed, bubbles of interest. Um, and then our CTO, who had experience implementing AI, so he came in and basically it was a pretty much uh, initially a top-down approach. The challenges we were facing at that point was the teams that were using AI were not talking to each other. Um, ExoStar provides services in highly regulated industries, mainly the aviation industry. So there were a lot of constraints related to compliance and regulations. So it felt like AI is not going to work for us. So we started with, small experimentations, and fast forward to today. We have multiple agents working within teams. I'm going to show you some data to talk about what the current day looks like, the real world results. But some of the interventions that really helped us was that, as I said, it started as a top down. We also started, more grassroots level involvement with an AI center of excellence where we encourage people to come and experiment. The culture became fail fast, learn fast. We had a wonderful hackathon last year. 22 teams from across the world participated, and the ideas that came through, uh, we implemented them. Some were in products and some were in internal practices. And of course, the normal things that help when you're trying to bring about transformation, AI training, and then everybody got licenses, um, enterprise level licenses. So that really helped. One of the interesting things that I felt is that happened was we were changing the ways of working initially, but we were not changing our underlying processes. And people were going to old ways of doing things. And so we realized that transformation cannot happen if we're just changing the ways of working and not updating our SLAs, our SOPs, and basically all the processes, especially when we onboard new teams and new team members. So there was a lot of AI innovation that was encouraged at the teams level, and we started seeing a lot of ideas. So let's look at some of the results that we have, just 1 year after we started. So we have about 87% adoption across the organization. And the couple of teams that are not using a whole lot of AI is just the way some of those contracts are set up, that we are unable to do a whole lot of AI there. But all the teams who are able to, 87% is a huge number in 1 year. Um, so our productivity lift is plus 144%. That's a huge number. Again, thinking about it's just been about a year. So this is an interesting metric. We added about 112 people's worth of um, capacity without adding even a single human being. So in a year, we have 112 extra developers that came just from using agents. That's how many deliveries we had, and also our lead time reduction. So we cut down our lead time by almost 20%. So these are huge numbers, which hopefully those of you who are thinking about embarking on this journey, to inspire you or motivate you. All right, so that's the big question that is the crux of our discussion today. So are AI coding agents making your software better or just faster? So anybody in the audience who are using coding agents, can you share some of your experiences with us? Quiet group today. Dave, I know your team has been using AI. What's some experience from your organization? All right, I'm not hearing anything, so maybe I'm going to move forward if that's okay. All right, so let's talk about, is faster or better, which is better, right? What I'm trying to say. Faster is not the same as better. Uh, so what we are seeing across organizations is that they are gaining a lot of speed, but then they're also noticing that there are a lot of challenges, and therefore faster is not the same as better. So the productivity has gone up, but some of the teams are not set up the right way to be able to enjoy the benefits that are coming from the speed. So, for example, teams that are using coding agents, they're producing much faster, but the validation and the testing hasn't caught up. Their processes haven't caught up. So we're definitely seeing a lot faster, but we're not seeing the other benefits that should come with that. Um, High percentage of failure rates. So we're seeing about 40 to 41%, more bugs than we did with traditional software development. Also, the way organizations are measuring is not customized for AI. So a lot of the metrics are also at fault because um, teams are showing these results to their leaders, but it's not telling them the whole truth. So it seems like they're doing a lot better, but a lot of the actual metrics that reveals the real benefits, the tangible benefits, are missing from that. So in appearance, it definitely feels like, hey, we gained a lot, but in reality, that's not the case. So let's talk about the good, the bad, and the ugly, because that's the topic for today. Um, so definitely, we are seeing that AI coding agents are changing the game. Let's look at some of the numbers, right? So definitely 55% plus on isolated tasks. We are seeing the benefits that are coming from coding agents. Um, some of the highlights, as you can see on the right-hand side, the routine code that 8 hours took time, so much time, repeatable, I would almost say mundane task. All that is done so fast by the coding agents, right? What used to take weeks now takes days. What used to take days now can be done in minutes. QA teams who have adopted AI, um, unbelievable amount of test coverage, and the speed at which they can test and produce results is definitely very fast. So definitely seeing a whole lot of benefits in those areas. Uh, we are seeing a huge amount of gains also in pull requests, right? Definitely a whole lot of gain in that area. So about 12 to 22% more pull requests are happening right now. That's just because of the gained efficiencies that we're getting. Let's talk about the bad. So in general, there is a problem with reliability, right? So the code that we have today, it works. 6 months from now, it's hard to predict whether that code that we have today is going to work because the dynamic speed at which we are developing. We talked about the bug rate increase. There's a whole lot for at 41% is a huge number. Um, the other problem that I'm seeing personally with teams is that teams are becoming over reliant on agents, and they're not doing as much peer reviews as much as needed, and that is almost laziness or over reliance will definitely have impacts in the long run. So these are some of the things that we're seeing. All right, let's talk about the ugly. Where did it go? Yeah. Okay, sorry about that. All right. So the ugly part is the pressure, right? The teams that initially started, um, they had amazing results. And now the new teams that are adopting AI, they are seeing a lot more pressure because of the numbers that are shared at the end of every speed. Um, as I said, quality is decreasing because the testing teams have still haven't caught up with the amount of code that is being developed, and also the amount of validation that is needed is also increased multifold. So the need for better testing, the need for end-to-end testing, and the need for human testing. The teams that are using AI for coding as well as using AI for testing, uh, they're seeing really varied results from sprint to sprint. So now that begs the question, right? So if you are embarking on a journey to bring in coding agents, what might be the best way to do that, right? Who should be doing the heavy lifting, especially if you're starting off now? And I'm going to talk about in the next slide some of the mistakes that I see that I've seen with my teams, and also talking to people in the industry, some of the challenges that are happening. So the most important thing here is, right, when you are designing your systems for the future, when you are updating the way your organization is building software, the most important thing here is to really have a very balanced approach towards it. Because if you go too fast, too early, chances are that you're going to see a lot more failures. So some of the bads and the ugly that we saw, you're going to see a lot of that. So the question is, how do you strike that balance, right? It's hard to know because every organization is different. Every organization's culture is different. The skills that the team members have might be also very different. And industries, as you might be seeing, each industry is applying AI in a different way. And it's so different than other things that have come to the technology world where it came and it took X number of years and then it got implemented and people got maturity out of it. AI has just been so dynamic. Just in the last since January, we have seen so much changes in the way organizations are building software. Um, so here's something to think about, right? This is called the autonomy dial. How much should you rely on humans versus machines? Um, so this is actually part of my upcoming book. So the dial actually in the picture you can see everything, right? So your organization needs to have a very balanced, a very strategic way of implementing coding agents. Um, and following this scale can help you, right? So the first one is when your organization is pretty new. Um, the humans do most of the work, and then you take assistance of AI as needed. As you mature and go to the next level, comes the next part where the human is leading and the agent is executing. So the second, sorry, I missed one part because I had the animation here. So when does the human doing the work and the agent assisting, what is it best suited for? This is where you have new workflows or, there are high stakes. You definitely want a reliable and things that the teams are more comfortable to work with. The human leading and the agent execution part, this is where, the teams have had some experience, and the work that they're doing is known to them. So this is where, this you can further your experimentation where you are leading it and the agent is executing. The third is again the next level higher. So you have set guardrails within which your agents are going to work, and the human is not as present as it was in number two. So it's a shared authority. There is a level of autonomy that is given to your agents. So that's the third level. The fourth level is the agent is doing most of the work, and the human is governing it, making sure the right things are in the right place, making sure that the validation is done. Uh, it's very workflow based. It's almost fully automated. So not a lot of organizations are at that level, but this is the direction in which we are going, and pretty dynamically. The last one is pretty much fully autonomous, right? So the agent does all of the operations, and the human is just doing the auditing part or just gets the reports. And if there is any changes that need to be done, they bring about that change. So this is a pretty important step for organizations to think through and also iteratively grow from one to five. If you go very fast, chances are you will stumble, you'll fall, and your progress gets stalled, right? Um, so three takeaways from the things that I've shared, right? Um, it's important to know what to measure. It's important to know where you are today. If you don't understand the capabilities of your organization, if you don't have a good inventory of the skills you have, and if you already had inherent software development problems and you bring in AI without making changes to the processes, um, AI is not going to solve your problems. In fact, AI is going to amplify and is going to make a transparency where the problems you already have become even more, problematic for you. Now, let's talk about discipline, right? So, when you bring in these powers, right? We are trying to bring in these powers of AI to your organization. There has to be a good rhythm that needs to be set. And sometimes it takes a long time for teams to find that rhythm. So, till the teams get into that discipline of doing things the right way, um, don't make too many changes at the same time. What I've personally seen as a transformation coach is that there is one problem that happens because of change fatigue, because too many things are happening at the same time. Second, a lot of people are very conservative or skeptic to start with. And in the beginning, if they start seeing a lot of failures, uh, they don't feel very encouraged to go further. So teaching them the skills, building the discipline before you go full steam is going to be very important. And last but not least, you've heard and seen so many cases um, from a perspective of ethics. Starting this year from January, you've seen a lot more regulations have come in place. So keeping the humans in the driver's seat is going to be extremely important. You saw the stages in the last slide. Don't be in a hurry to get there. Uh, Help the teams, coach them, change your processes, and iteratively develop and go in that path. So I think that's what I had, and I'm going to pass over to our guru, Uday, who's going to be talking about the same things, the good, the bad, and the ugly, but he's going to be talking more from a technology perspective. I was covering more from an implementation perspective. Without further ado, please help me welcome our next speaker, Uday.
Thanks, Toby. Uh, Thanks, Meenakshi. Go to the next slide. Think we covered the background and everything, so I don't need to harp more on that. Let me cover the premise here. As Toby was mentioning 2 years ago, most of these were demos. Today, they are real drivers. The list here keeps growing. Look at what we measure on the right side is you will see that can someone read the code on the left side first. Let's see what we actually measure. We actually can say that does the code pass the test? How fast did it ship? How many lines it generated? How many tickets that were closed? All important things. They are necessary, but I think they are not sufficient. On the right side, which are the real important metrics, right? Can someone read this after 6 months? Does it fit the system architecture? Did the model actually understand the bug? Or it just was going around in that reasoning mode? What is the total cost of ownership? The gap is what this whole talk is about. Next slide. Let's start with the good. I think Toby covered it, and I'll highlight some of that. I want to spend some time over here. And as Toby mentioned in his dial diagram, as well as in his talk, the single biggest win in my view is in prototyping speed. What used to take like days, as he mentioned, can take now hours and even shorter. But the part that does not get enough attention is the thinking partner role. Like very few people I know actually use brainstorming skills to actually have that constant iteration with the agent. Rubber duck debugging that talks back is, to me, like the most important idea. That does not show up in any productivity metric, but many developers tell me this is the highest value that they have found, including me. Next slide. The boilerplate test documentation. 3 categories where agents are unambiguously excellent, in my view, are scaffolding, project setup, config, CRUD operations, API stubs, all the basic things that can be easily done, verified across all the languages. I've tested it in Java, C, C++, and Python. I use Python a lot, but all of them. Testing, readmes, documentations, all of this, like PR descriptions, commit information, all of this is very well established pattern, tedious but not hard, and you can immediately give a feedback, and this is where the agents excel. Next slide. Migration at scale, framework version bumps, API deprecation, cleanups, code base wide renames, all the grunt work can be now speeded up, can be done at an amazing speed with these tools. Why do all these tasks work so well? Low ambiguity, bounded scope, fast feedback, and high pattern density. Going through like all the existing GitHub, a large language model could generalize this much more easily. Next slide. So this is a practical case study. Before we move on, I wanted to show the good at scale. OpenHands is an open source AI coding agent that has been built in large part using AI coding agents. 50,000 GitHub stars, 3,500 commits, and more than 250 unique contributors. This is not a demo, but a real system. This is a production project where AI agents are doing exactly what we described: scaffolding, refactoring, routine automation at a scale. It started as OpenDevin, grew into a model agnostic platform backed by CMU researchers and professor I know really well, Dr. Graham Newbigin, and has now formed a dedicated company. They are all driving the evaluation work I just showed you. EvoClaw, Skills Bench, the skill evaluation tutorial all come from this community. The good is real. It is at scale. It includes everything from generation to evaluation. Next slide. So on the left side, there are 3 columns here. The build tooling, the agent skills as standard with reusable skills as a markdown packages for coding, testing, security. You can go to Claude or any of these and you will get that skills framework. 50 plus community contributed skills in Anthropic and Composio HQ repositories. Open source platforms like OpenHands each have GUI and SDK access for doing this. In the middle column, something newer and more important: evaluation infrastructure. EvoClaw benchmarks continuous software evaluation across various models, the foundation models, and various agentic frameworks. And you will find that agent scores drop over 80% on isolated tasks to under 38% when they have to maintain their own code over time. And we'll discuss that in detail. And on the right is operational benchmark. What are the benchmarks you are using to testing? SWE bench verified 53% on real GitHub issues. The OpenHands has an index that has a live leaderboard There is SWE, efficiency tracking. There are various things that have been continuously added to monitor and operationalize. Next slide. I'm not able to see the slide.
Okay, Toby, we can't see this. I mean, I can see the
Oh,
slide, but
okay, I can see it now. Okay.
okay, all right.
Now, these tools have earned a permanent place in how we work. But notice what we have been careful to talk about. The tasks are bounded, the stakes are low, the patterns are dense. What happens when one of these conditions or all of these conditions change? So that is what we will talk about, the bad part. So the code that passes every test but fails every review. Let's discuss that. Next slide. I'm not seeing the change in slide again.
Um,
Okay.
I can see the,
there is
yeah.
a delay, maybe. Okay.
Okay. So go a slide before. I think it moved to, okay, go to the next slide. That's okay. So this is an important slide, which is slop code bench. This is from Orlansky and colleagues. Instead of the normal SWE bench I mentioned, slop code bench it came out just a month ago. 20 problems, 93 checkpoints, 11 models, and here is what it makes different from other. Most benchmarks are single shot. Slop code bench is iterative. It wants to show that your agents are generating slop, just like LLMs generate slop. If you are not careful, if you don't have guardrails. At checkpoint 1, the agent implements from scratch. At checkpoint 2, it extends its own prior code and it goes to the 8 checkpoints. The critical design choice, the agent's own code carries forward. No gold standard reference replaces its work between the turns. If it hardcodes something at checkpoint 1, it pays at checkpoint 3. Bad architecture has a compounding impact. This gives a clean code and a bad code between code flow bench, SWE bench, slop code bench is the real one because this is what happens in the real world. That is, no one just keeps changing. There is a constant uh, revision, there is constant change in the code, and you have to keep extending and making and refactoring your code. And that is what slop code bench measures. Next slide. So how does it measure? I will not go too much into the math and the details. So the first one is, at least what is structural erosion. It's a complexity spreading evenly or piling into a few small functions. For each function, like if based upon C, Python, etc., it is a complexity mass. Cyclomatic complexity times the square root of source lines, etc., etc. So if there is if, for, while, case, big branchy function, it has a high mass. A small linear helper has low mass. Next is erosion. Erosion is a fraction of total mass in functions above a threshold. If erosion is 0, every function is clean. If erosion is 0.8, 80% of your complexity is jammed into these massive functions. The paper has a function that grows this complexity over 8 checkpoints, as we discussed. And this gives you what passes and how the complexity evolves. Next slide. The next thing is, just like LLMs can generate a lot of slop, the code can have slop, and that is measured through verbosity. Verbosity is count lines flagged by various rules called as AST-GREP rules or detected as duplicated code. Divide by total lines, that is the fraction of your code base that is redundant. So on the left, the flag patterns, identity list, comprehensions, unnecessary conditionals, redundant temp variables, things a reviewer catches immediately, but no test suite will ever catch that if not in the guardrails. And on the right, clone detections. Agents generate the same logic in 3 places rather than extracting a single shared function. So this gives you an idea of how verbosity or slop increases. Next slide. The headline numbers, 0% of problems solved end-to-end by any agent. 80% of trajectories show rising erosion. Nearly 90% show rising verbosity. Agent code is 2.2 times more verbose than human repos. And the last bullet, prompt intervention shifts the intercept, not the slope. You can tell the agent to write cleaner code. It starts cleaner, but the degradation rate is the same. The slope are parallel. Prompting does not solve the compounding problem. So that's an important real metric, real bench across all the models. Next slide. I will not go over it since Toby can share the slide. It has like reference to my own implementation and how I have reproduced all of this. So I will not go through some of that over here. Next slide. Yeah, it's the same detail about, you can read that on my Substack or on the slides. Let's go to the ugly part. Now, we saw the good part, the bad part, where we could measure the metric when the benchmark is complex, compare it to like the easier benchmarks and see what the bad part can be. That is, if there are multiple checkpoints, if there is an evolution, things get really bad. Now we'll see the ugly. The cost that you cannot see until it is too late. That's the definition of ugly. Let's go to the next slide.
I'm on the next slide, Uday, already.
Oh,
This is-
okay.
yeah.
Okay, sorry. It is having a delay. So 60 to 80% of total software cost is not in building it. It is actually in maintaining it. Requirements evolve, teams change. A decision in sprint 3 has a consequence in, say, sprint 11. When we evaluate an agent on a single fix, we are measuring something that does not exist in production. A static, self-contained problem with no history and no future. So that becomes the most important thing. How do we actually measure? Next. So SWCI from Sun Yat-sen University and Alibaba, both from China, 100 tasks, 18 models. Each task spans 233 days of real development, 71 consecutive commits. The agent gets a kind of like a budget of 20 iteration. The agent starts with the base code and gets the Oracle test suite, the tests that pass against the target but fail against the current state. No human issue description, just CI output. The dual agent architecture, an architect agent takes the stack trace and converts them into structured requirement. And the programmer agent reads those and modifies the code. They cycle until convergence or their budget gets exhausted. Next slide. And that is where Evo score, that is, how do you measure the trajectory? Why pass rate is not enough? A fast brittle fix at iteration 3 looks great on a snapshot. If it breaks something at iteration 5, 8, 12, pass rate never captures the cost. Evo scores works in two steps. First, at each iteration, it computes a normalized change. Positive means test fixed, negative means test broken. Regression count against you. Second, aggregate with future weighted parameter. Later iterations matter more. This rewards agents whose code stays healthy over time. The zero regression rate, that is below 0.25 for 0.25 for most models, in 3 out of 4 tasks, the model broke something already working. Only Claude Opus 4.5 and 4.6 exceed 0.5. They fix what is in front of them and break what is behind them. Next slide. Again, next slide.
Yeah, this is the compounding effect.
Can you go next slide? A slide more.
I think there is a delay there.
Oh, okay. Go to the compounding effect. Sorry. So translating the research into what it looks like on the ground, month 1, agent closes 50% more ticket. People celebrate. Sprint velocity looks amazing. I think Toby highlighted this. Month 6, debugging time increases. People say the code base has gotten complex. Nobody connects it to the agent code. Month 12, new team members cannot ramp up. Nobody knows why it was built this way. Because nobody built it, it was generated, checkpoint by checkpoint. Each one locally reasonable, globally it becomes incoherent. The gain in generation is offset by the loss in maintenance, invisible in sprint metrics. Next slide.
Scary.
Yeah. Debugging is causal understanding. One more layer. Debugging is about causal understanding, tracing execution path, understanding the state, reasoning about interactions. What if the agent's reasoning, the chain of thought that it shows, that looks very careful, is all performative and it is not real? And that is where another research comes into picture. Next slide, please. The reasoning theater. This is a great paper. This is what the reasoning theater research reveals. On the left, what it looks like, step-by-step analysis, trade-off evaluation. The agent says it traces the null pointer to the constructor and gives you all interesting performative information. On the right, you really don't know if the reasoning trace is a narrative applied after the statistical prediction was already made. I have written extensively on this and demonstrated it in the next slides, and you will see that what we think that the model is doing behind the scene, giving you all the explanation, is, and what you think as a proxy of reliability is not. It is a theater. You cannot trust the explanation any more than you can trust the code it generated. So just having that is very important, because it is just a performative thing they keep all LLMs do to generate more tokens because they want to match the token. Even though they know the answer, they keep pushing unnecessary information just to show that it is thinking hard, but in practice, it is not. So next slide. So I have done my own research on reasoning theater. Again, my detailed code and all of that is available, and it clearly shows, at least in my research, as well as like collaborating with other researchers, how there is like an early exit at 95% probe confidence saves 68% of tokens while retaining 97% of accuracy. That is, if I stop LLMs to uh, at very early, that is right at the start, then I get the same accuracy that and save 68% of the tokens that it does as a performative theater, which is just wasting the dollars. Next slide. So what do we do? Next slide. So 3 layers of defense. First, go beyond the functional test. Track erosion and verbosity, not just the pass rate. Treat AI PRs with the same rigor you would apply to a junior developer's code or even a senior developer's code. Maybe more, because the developer builds context as they write. The agent does not. Second, maintenance-aware development. Track the trajectory metrics, not just the snapshot. Monitor zero regression rate in CI. Human designs the architecture, agent fills the implementation. Build a culture where the periodic rewrites are preferred over perpetual patching. The research shows extending eroded code always makes it worse. Third, healthy skepticism of reasoning. Verify output independently. Chain of thought is conversation aid, not a proof. The statement the agent explained why this worked is not same as I understand why this worked. Test the hypothesis. Do not trust the narrative. So, last slide is the closing. Use the agents. I mean that. The good parts are genuinely good. As I showed, OpenHands has 50,000 stars for a reason. The build, evaluate, and operate is real and growing. But be the senior engineer in the room, even when the agent sounds more confident than before. So make sure you use the right metrics as I showed and the benchmarks, and that should make sure that you are on the right. Thanks.
All right, we'll open it up for questions. Any questions in the chat? Lots of comments. I'm just noticing. Don't see any questions yet.
Okay.
Oh, hello. Can you hear me?
Yes.
Now we
Oh,
can.
I had my hand up. I don't know. I didn't know if you could see it or not.
Aaron.
Oh, yep, great. Thank you so much for a phenomenal presentation. So I have a question about tool chains, right? Because most enterprise environments, you are constrained by either your custom dev tool chain, Java or .NET, or both in some cases, or other open source, or package environments. And in the package environments, there's a lot of let's just call it sort of bolt-on AI. That's the companies are sort of pushing out, SAP and Oracle, others. And then on the custom side, I'm finding it's much more of like parallel development teams. It reminds me a lot of during the 2000s, you would have different module teams, and then you'd really try to figure it out in integration test and sort of determine if the design was correct then, which was obviously too late. And then we sort of installed these large test suites and development systems behind them. Do you find that there's any approaches, because we're all Jirified now, we all have all the different test suites that we should be adding, any type of tool chains we should be adding, or approaches within those two tool chains to drive more verification, because those tool chains really aren't designed for this type of verification and validation. Like the old V&V work is a little different for AI than it is for business rules, let's say. I mean, this sort of reminds me of business rules, like in the 90s and early 2000s, when you would do business rule development. You couldn't do that without a real business analyst and a functional power user, because you don't know anything about the business. You're a developer, right? So I don't know if that makes sense, but just, what approach have you seen works given the constraints of all the tools that we have around us, and the tool chains that we've been sort of optimizing around?
I'll give my 2 cents. Toby can give his. I have seen, again, like my view is like what I have used personally and what we use at work. And I've heard from everyone, like everyone uses different, like whether it is Codex or it is Claude Code or OpenDevin or X or Y, whether they use it as assist or they use it through the skills framework. I feel that each organization needs to have, at least that is how I work and my organization or my team works, is we have extended, like if we are using Claude Code, for instance, their whole skills framework, the best practices in the skills framework, we have modified it to map it to our organizations need in terms of mapping what are the things we actually care for, how do we actually want the code to be written, what are our best practices, what is the taxonomy we follow. All of that is just like, as you mentioned, a business analyst, a kind of an analyst replicates that in the skills. Once you have it in the skills, Claude Code or any of the tool will kind of respect that and actually will follow that, and you can have a shared primitive that shows how it is being used, and actually in all of can follow that to the T. So that is what the principles we have been using.
Yeah, so just to add to that, Aaron, I didn't hear you mention anything about TDD or BDD, and those
No, I
are,
didn't go there, but yeah. So
yeah,
HDD, BDD, or
yeah,
XDD as I call it.
yeah.
Or,
So test-driven development and business-driven development, right? These two still hold water, because a lot of organizations are still going through this transition. Uh, I don't know of many organizations where, all the work is being done by coding agents. Many organizations are going through that transition. So taking drastic steps to stop everything you were doing to like full automation, I'm not seeing that, at least from the folks that I'm speaking to. So what I've seen in the last year and a half in my organization, three things that we are doing. One, we are shifting testing to the left. We are moving from stories which are written for human beings to specs, which is being written for agents, and a thorough readiness evaluation of these specs is being done earlier. So the idea is to catch any imperfections early. As you've seen in Uday's slide, there is a compounding effect when a glitch or a bug or an anomaly is introduced and it is not caught, it amplifies and expands in size, and it's more costly to fix afterwards. So that's one thing that we are doing. Second is automate first stance. Um, the need for testing faster, the need for testing more often, and the need for testing much earlier is a huge pressure. Um, the speed at which development takes place versus the speed at which testing takes place has to come to a par, right? So a huge impetus on automation is happening. I'll stop there because there are a few other questions. Aaron, I hope that answered your questions.
No, thank you so much. I appreciate it.
Right, so there's one question here earlier. I want to make sure we don't miss this from Olaf. And this is, I think, Uday's slides. How can we build this long-lasting tests?
So there is no one secret here. The idea of you need to formulate your testing and evolve your testing in the same way as you evolve your code. That is the most important part of it. If you are comparing it with the benchmark can't be a static one-shot measure of something. Just like your code evolves, your test evolves, your benchmark has to take into consideration the evolution perspective. So your test can't be static. This test has to look at both uh, the old and the new, how things have changed, and the benchmark has to capture the delta between the two.
All right, I think we are on time, but Meenakshi, other questions?
No, I don't see anything in the chat. And thank you so much for there are comments, but no questions. So thank you everyone for attending, and we look forward to seeing you again on the second Thursday of the month in June. You'll see us on LinkedIn. You'll get our invites in the email, so definitely RSVP there. It's an AI topic, of course, and I don't know if Nisha is here. I know she
She
came
is.
in. All right. And
I
our
am.
hey,
Hey, Meenakshi.
hey, and Nisha here will be presenting on AI and testing ecosystem. So bring all your testing questions and curiosity. We look forward to seeing you all.
Absolutely. Looking forward to that.
Thank you.
Thank you,
Talk soon.
everybody.
See you all soon. Take care. Bye-bye.